Welcome to Planetary Possibilities. I'm your host, Aria, and today we're diving into what might be the most sudden and catastrophic climate event in human history. Imagine waking up in a world that's gradually warming after the Ice Age, with thriving ecosystems and expanding human settlements, only to have everything plunge back into freezing conditions within a single decade. This isn't science fiction. It's the Younger Dryas, a climate mystery that occurred roughly 12,800 years ago and transformed our planet almost overnight. The evidence is written in ice cores, geological records, and even the disappearance of entire species of megafauna that had survived for millions of years. Was it a comet slamming into Earth? A massive freshwater flood disrupting ocean currents? Or something else entirely? Join me as we piece together the clues of this forgotten apocalypse that not only reshaped our planet, but might have forever altered the course of human civilization. Before the icy grip of the Younger Dryas, Earth basked in a period of warmth and abundance. This era, often referred to as the bowling alley interstadial, was a time when the planet experienced a significant climatic shift. Temperatures were rising, ice sheets were retreating, and sea levels were on the rise. The climate was warmer and wetter, leading to the proliferation of plant life. Forests carpeted the land in a vibrant tapestry of green. Megafauna, those giants of the prehistoric world, thrived in this period. These large animals, such as mammoths and giant sloths, roamed the land. Mammoths, with their long curved tusks and thick woolly coats, roamed the grasslands. These majestic creatures were well adapted to the changing climate, their size and strength allowing them to traverse vast distances in search of food. Giant sloths, lumbering but gentle giants, browsed on the abundant vegetation. These slow-moving herbivores played a crucial role in shaping the landscape, their feeding habits helping to maintain the balance of the ecosystem. The skies were filled with flocks of birds, their calls echoing through the forests. These avian inhabitants added to the richness of the environment, their migrations and nesting behaviors contributing to the dynamic nature of the ecosystem. This was a golden age for life on Earth. The combination of a favorable climate and abundant resources created an environment where life could thrive. During this period, we also saw the rise of early humans. These early inhabitants of the Earth were resourceful and adaptable, taking full advantage of the bountiful environment around them. They were hunter-gatherers, skilled trackers, and resourceful survivors. Their knowledge of the land and its resources allowed them to thrive in this changing world. They hunted game and gathered fruits, nuts, and roots, ensuring their survival and prosperity. They lived in small nomadic groups, moving with the seasons and the availability of food. This mobility allowed them to exploit different resources throughout the year, ensuring a steady supply of food and materials. The bowling alley interstadial, with its favorable climate and abundant resources, provided an ideal environment for these early humans to flourish. This golden age laid the foundation for the future of human civilization. And then, out of seemingly nowhere, the Younger Dryas appears. The transition was swift, almost as if nature had flipped a switch. One moment, the world was basking in the warmth of a gradually receding ice age, and the next, it was thrust back into the icy grip of a near-glacial state. This sudden shift was a stark contrast to the gradual warming that had been occurring over thousands of years. The Earth had been slowly emerging from the last glacial maximum, with temperatures rising and ice sheets retreating. But the Younger Dryas descended upon the Earth with a vengeance, plunging the planet back into a near-glacial state. The icy winds swept across continents, bringing with them a chill that would reshape the world. Temperatures plummeted, dropping by as much as 10 degrees Celsius in some regions. This was not a gradual decline, but a rapid and severe drop that left little time for adaptation. This dramatic shift occurred over a remarkably short period, perhaps within a few decades or even less, marking one of the most abrupt climate change events in Earth's history. Glaciers that had been retreating began to advance once more, covering the land in ice. The effects of this sudden freeze were catastrophic. Ecosystems that had been thriving in the warmer climate were suddenly thrown into chaos. The onset of the Younger Dryas brought not just a change in temperature, but also a shift in weather patterns. Storms became more frequent and intense, and the weather became increasingly unpredictable. The warming climate had brought increased rainfall to many regions, but the Younger Dryas ushered in an era of aridity. Rain became scarce, replaced by dry winds that swept across the frozen landscapes. These winds, carrying dust and ice crystals, further exacerbated the already harsh conditions. The dust and ice particles in the air made breathing difficult and reduced visibility. The world, once vibrant and teeming with life, was now a desolate and unforgiving place. The landscapes that had been full of colour and movement were now monochrome and still, a true reminder of the power of nature's forces. Let's discuss the competing theories that attempt to explain the sudden onset of the Younger Dryas. The first theory is the comet impact hypothesis, which suggests that a comet or asteroid struck the Earth, causing massive fires and a sudden cooling effect. Proponents of this theory point to layers of microscopic diamonds, known as nanodiamonds, found in sediment layers dating back to the Younger Dryas. The second theory involves ocean circulation disruption. This hypothesis posits that a massive influx of fresh water from melting ice sheets disrupted the Atlantic meridional overturning circulation, or AMOC. The AMOC is a crucial component of Earth's climate system, transporting warm water from the tropics to the North Atlantic. When this circulation is disrupted, it can lead to a rapid cooling of the Northern Hemisphere. Additionally, other theories have been proposed. One such theory involves increased volcanic activity. Large volcanic eruptions can release vast amounts of ash and aerosols into the atmosphere, reflecting sunlight and causing a cooling effect. While there is some evidence of increased volcanic activity during the Younger Dryas, it remains unclear if this alone could account for the dramatic climate change. Another theory considers the possibility of a solar minimum. A solar minimum is a period of reduced solar activity, which can lead to lower global temperatures. However, this theory also faces challenges, as the timing and extent of solar activity during this period are still subjects of ongoing research. Each of these theories has its own set of evidence and challenges, and scientists continue to debate which, if any, is the definitive cause of this dramatic climate event. As we unravel the mysteries behind the Younger Dryas, a pressing question looms large. Could it happen again? To answer this, we must first understand the factors that contributed to this abrupt climate shift and assess whether similar conditions could prevail in our modern world. One of the prime suspects in the Younger Dryas event is the disruption of ocean circulation. Today, the Atlantic meridional overturning circulation, or AMOC, remains a critical part of our climate system. Recent studies indicate that the AMOC is weakening due to global warming and the influx of fresh water from melting ice sheets, much like what might have happened thousands of years ago. If this trend continues, we could potentially face a similar rapid cooling event, though the exact outcomes are uncertain to say the least. The comet impact hypothesis, while less likely to recur in the same manner, cannot be entirely ruled out. Near-Earth objects continue to pose a threat. Volcanic activity is another factor worth considering. Large volcanic eruptions have historically led to short-term cooling effects, sometimes referred to as volcanic winters. With many volcanoes around the world still active, the possibility of a significant eruption remains a valid concern. The notion of a solar minimum also adds another layer to this complex equation. While we are currently in a period of relatively high solar activity, solar cycles are unpredictable. A future prolonged solar minimum could again contribute to global cooling, although it would likely need to coincide with other factors to create an effect as dramatic as the Younger Dryas. While the exact conditions of the Younger Dryas may not replicate themselves precisely, the mechanisms behind such abrupt climate changes offer valuable lessons. The Younger Dryas remains one of the most enigmatic periods in our planet's history. From the sudden onset of an ice age to theories involving ocean currents, comet impacts, and volcanic eruptions, we've explored the many facets of this ancient mystery. The Younger Dryas stands as a warning from history, urging us to pay close attention to the signs and signals of our own time. If you found this look into the Younger Dryas insightful, please like and subscribe for more deep dives into the mysteries of our world and universe. And come back next week for another episode of Planetary Possibilities.